Hello everyone, welcome back to Zhan's AI Corner, where I use plain English to teach you how large language module works. The topic I want to talk about today is called LoRA, aka we call it low rank adaptation, right? So let me just put my explanation here, which is aka low rank adaptation, right? So what LoRA does, right? In the past video, I kind of introduced the RAG, where RAG is able to help large language module with answering the question effectively and accurately, right? If you are not familiar with what RAG is, or you want to know how it works, please feel free to go to my past video to learn about it. So while RAG is indeed an effective solution to address the context window size limitation and also enable large language module to acquire specific domain knowledge. However, it does require a more complex architecture. For example, it requires at least additional embedding large language module, right? Also, you need a vector database to store those embeddings. And you need your customized code, you need to write a code to orchestration the work between the general large language module, which are sometimes I call the foundation module, and the RAG solution. And then not to mention, right, one of the biggest drawbacks for RAG is it actually consumes the context window, which is supposed to be reserved for user to interact with large language module. So while when we use LoRA, on the other hand, it does a similar work as a RAG. However, it provides you the similar. It is a similar solution to let a large language module have additional domain knowledge. However, instead of consuming the context window for injecting the domain knowledge, it actually inserts the knowledge into large language module. Make the large language module have additional knowledge adds on besides the data is already trained on. Right? Therefore, after you use LoRA for training, or I will say tuning the large language module, you have your custom large language module based on your training data. Hence, you do not need to build a whole RAG solution, and you can just start calling your custom language module, like how you calling large language module foundation modules like Gemini, DeepSeek, Llama, etc. So how it works, right? So we know in the RAG world, right? So you have the vector database, right? And then you have the, let's say this is the generative large language module, which is like Llama, and also you have the embedding, right? And then you have your code, right? Your code, right? That they have to work together. They have to work together, right? Generative AI call your code get called embedding large language module, right? And the large language module come back with large language module come back with the embedding value. Then you start query the vector database to storing and retrieving the data. So that is how RAG works, right? This is called RAG. Can I just do this? Right. But in the LoRA world, so what happened is you actually start customizing your generative AI large language module. But on top of your generative large language module, you start using a tool which is very popular nowadays, a framework called PyTorch. right? And then you have your training data. And you use PyTorch to read this training data. Can I? And then get into your large language module. Right. So, and then by doing that, and LoRa will generate a few adapters. Which are on top of this generated large language module, and the whole block, this block, become your custom large language module, right? And in the future, you can just start calling this package or bundle, which is your custom large language module, right? So this is how it works. So LoRa is a part of PEFT, right? If you don't know what the PEFT is, yeah, PEFT is aka for parameter effective fine tuning, right? Efficient fine tuning. So it's a part of fine tuning, right? So, but it takes significant comparing with like a full tuning, right? So if you heard like there are parameter effective fine tuning, so what's the differences between PEFT and the full parameter tuning? Of course, it takes significantly less time to train your large language module, customize your large language module, and also it consumes much less GPU resources, right? But before we jump into LoRa, even I'm talking about a lot of good things about LoRa, but before you actually start doing the LoRa work, so I want to address a few limitations of LoRa, and so for your consideration. So first, after fine tuning, right, your large language your customized large language module is still based on the base module, right? For example, you are using Queen. If for example, you use Haiku, right? They still Haiku module. It's just you're just adding additional layer in my language adapters to having the base module have a specific knowledge, additional knowledge. So, but how this large language module, your custom large language module will behave, it will still have the same behavior as the base module, but it just have additional knowledge. That's number one, right? Number two, LoRa cannot dynamically adding the real-time information into large language module. That means if the knowledge you intend to customizing your large language module is dynamic, for example, you want to give the latest financial stats, LoRa will not be the best practice. You're better off with RAG solution, which you can dynamically updating the vector database, and therefore having the base language module generative large language module able to give the dynamic information based on the real-time stats. Because what LoRa does is it will generate those adapter, which is a knowledge package in my word, and then unless you constantly updating those adapter, which is not practical and it will be expensive and time consuming. Otherwise, like this large language module is set, right? So therefore, keep that in mind, like before you jump into LoRa, want to fine tuning. But if you are trying to having your customized module based on some facts or your product, your company product, which is already concrete, is less likely to be changed, LoRa would be effective solution comparing with RAG, which is require a more complex environment ecosystem to run RAG. Because LoRa, which is to give you a customized large language module, and you can use it as a normal large language module after you tuned, right? So that is like the trade, That is how you want to use, when do you want to use RAG and when do you want to use LoRa, right? So the next, let's get our hands dirty a little bit and looking at how actually we can use LoRa to fine tuning a large language module, right? That will be more interesting, right? So let's get started. So right now I have the code which is over here, so we can just close the others, right? So on the screen is a Python code which is doing the tuning. So at the beginning, it's importing PyTorch library, but I will cut to the chase and go to important part. After importing the large language module, in my case, I'm actually getting from a Hugging Face, I believe, and then you start setting your training parameters, right? I here update, I put all comments for each parameter it means, right? So therefore, like I'm explaining how I actually train my customized large language module, all right? So there is parameter for output directory, which is like output. What is this? Is basically those adapter files, those files where it will be, right? So let's just say put in the out like in this folder, for example. And then like per device train batch size, right? I can make it bigger. So basically it's saying like how many training data sets you want to import, right? Higher the number is, the faster, but of course taking more GPU, right? And then gradient accumulation steps, how many batch in each large module with update. Higher this number works the best with a smaller this number. Like, for example, if this is 1, it's best with 16, 632, something like that. But if the size, this size is batch size bigger, maybe you want to lower. It just depends on your hardware resources, right? And the learning rate, what it is, the step size for updating weights. Higher this number means faster is learning, but risk of forgetting the base module behavior, right? For example, if you want to set this value extremely high, then like it will be probably forgetting the base module, how it should behave. So you're trying to find a sweet point for this, right? And this number of trainings, like apples. How many times LoRa will check the training data? For example, like come back to look at the training data again. If you right now I set to 3, that means it will come back to check my training data for 3 times, right? Highest number means check more times. Good for smaller size training data because you want to make sure it is like repeated, emphasized, right? And the rest of the 2 parameter here basically for like the tuning, like for tuning accuracy, right? For me, I just set to false because in the example, my example size is pretty small, and data loader pin memory, right? Normally set to true, like to speed up between the GPU and the CPU. But for MacBook, I'm currently running on a MacBook, I set to false because it has a problem with setting to true with the Apple GPU. Login steps, basically login related, and this is a saving related. It's not so it's explain itself. And then where you want to report to, you can integrate with external platforms, right? And then we're talking about the next LoRa configuration files, right? There are a few parameters quite important with R, which is rank of the adapters. Higher this rank means the training data is more complex, right? You want 8 or 16, something like that, you can change based on a scenario. And the alpha basically is a scale. It's a value for scaling up the weight of your training data, right? So what I put here is for LoRa tuning knowledge scale purpose. Bigger this number, higher the weight for knowledge insert. Means your knowledge insert is more important, right? Drop up for adjust the possibility of to be more flexible with understanding training data. So this is interesting one. Something like if you set this value extremely low, like I'm setting the value pretty low, that means the large language module will literally just answer like based on the training data. If there is even small differences when the customer asking, large language module might not able to pick up the knowledge because the value is pretty low. But if you change this value to 0.1, for example, higher the number, then even maybe the customer is asking a slightly different way, but large language module will still able to pick it up. So this is for this kind of purpose, for the flexibility, right? And then target modules basically says like which layer you want to insert those like your training data, right? I put out here is the layer LoRA is applied to. If you still remember in my last video talking about how large language module works, there is a different layer like a QKV. Actually, they belong to attention layers. Right, attention layer. Right now I'm only touching the QKVO, which is attention layer, and because my large language module is very small. I'm using a 1.1 billion tiny llama module, right? So I just work on the QKV layer. But if you are using a more complex or bigger large language module, you should also consider like insert your knowledge into the MLP layers. Right, so what I put here is for small modules, attention layer probably will be enough. But for larger modules, you should include the MLP layer as well. So this is the layer I insert. And then at the end, I just say, okay, task type is casual, right? Tell the LoRA this is for auto-regression, large language moduling. So this is the important parameter is, and how you configure LoRA. And this is my training data. Because like I believe somewhere I mentioned my training data is my data.json, right? My data. Yeah, here we go. I said a loading data sets. So my loading data set is basically just a bunch of the instruction in JSON format. So okay, write a paragraph for presents great achievement. Then stay like this. So basically give a different example and the different answers, basically to try to train Llama, right? So if I want to do that, I think I already trained a little bit, but I can start training Llama, and I should say train this tiny Llama, then we'll start training. And it will probably take a while, right? You can see it start training now. So based on my training data, right? So actually start working. It might take a while based on your training, like your base module, larger module size, and also your training data. This time it's pretty big, pretty quick because I already done the training already. So just let me Python, maybe just say, let me say, I write a small class to call, yeah, I say, okay, so I'm Chinese, so I put Chinese. Please write a small article talk about Zhan, right? Based on training data, right? So Python run LoRA. See how it works. Come on, give it a shot. Because like Zhan is my name, right? So please write a song writing with a focus. And this article should be writing in a clear internal focus. Include what's this? Sorry, by Zhan Zhang Yi. No, this is not right. Maybe because my training data, remember like a training data, this value I set to the job pop I set to 0.5, where it is. Maybe I set the value too low, so it cannot like can only be very specific for, where is it, 0.5? Yeah, job pop rate, maybe too low. Let's just say very accurate, right? Just say, copy paste this. It should work this time. See, it started writing the things, right? It's based on the training material, and the large language module started talking about myself, right? So hopefully this video gives you some understanding about the whole LoRA is, how it works. And yeah, if you enjoyed this video, share with your friend and the family. I will see you next video. Talk to you later. Happy AI programming.